Greetings, and welcome to week 2 of our course, Revolutionizing Construction, a comprehensive guide to 3D concrete printing. In this week, we are looking into the materials to be used in 3D printing technology. Particularly in this video, I'll talk about the types of material for 3D printing for construction, and how they are formulated, and finally, some alternatives to the materials. Alright, let's dive in right away. In the field of 3D printing for construction, the right choice of material is definitely a paramount importance. As the name 3D concrete printing implies, the primary material of choice for this technique is going to be concrete. Before we get into the detail, I must give you a more basic elaboration on a few terminologies to clarify about this material: the paste, mortar, and concrete. First of all, paste. Paste is a simple blend of cement and water. It is a very basic bonding agent or like a cementing agent. In many cases, a portion of cement is replaced with mineral additives like fly ash, slag, and other stuff. Mortar is a mixture of paste that I mentioned just now and fine aggregate, which is a sand. It primarily serves as an adhesive, gluing building elements such as brick and the stones, glue them together. Concrete, in traditional construction field, represent the main structural material. The part component is a combination of cement, fine and coarse aggregates, water, and an array of mineral and chemical additives to adjust the functionality and also property of the concrete. Concrete can be found in a diverse construction projects, from a small house and towering skyscrapers to a robust civil structure, which is a bridge. Let's now start to talk about the material for 3D printing in construction. For the extrusion-based additive manufacturing technique, the mortar was the first material introduced to this technology. Since mortar primarily comprises of fine aggregates, or like the fine constituents, it was relatively easier to pump and extrude. You can make a lot of variation of material formulation, but it normally inherent the mixed design of high performance concrete, basically high cement, silica fume, chemical added mixtures constituent, and lower the water content. You can consider a number of factors when it comes to the mixed design formulation, such as packing density, plastic and drying shrinkage, mechanical and durability performances of concrete, and so on. As the technology advances, nowadays, concrete printing became feasible. Because of coarse aggregate, a different pump choice needs to be made for this technique especially, and we are going to discuss more in detail in the following week, week 3. No matter the material choice is going to be mortar or concrete, the printed material behavior in fresh state is very unique and important when it comes to design the material. The material should not strain the pump while it's being pumped, and it should retain its shape when it's being extruded. The previous printed layer, called filaments, should carry the load of the following printed layers. For the ease of pumping, we call it as pumpability. For the near zero deformation under its own weight before the following layer is deposited, as intertwined with the term extrudability or shape retention. For the degree of how it's well stacked together and without a noticeable structural or material failure, we call it as weldability. When all parameters are well matched or adjusted to the right level, it ensures each layer of printed materials adheres precisely to the one each other, forming a seamless, cohesive one good structure. As explained, the importance of consistency of fresh concrete cannot be overstated for 3D concrete printing, and it is closely related to a field of science called rheology. Rheology, in simple terms, pertains to how a fluid or semi-fluid materials flow and deform under pressure. Again, achieving the ideal consistency is the foremost importance in materials behavior, ensuring it's in the optimal state for extrusion while retaining the desired form. Many researchers and innovators are continuously exploring the potential of specialized cement-based material for 3D printing. Notable examples include formed concrete, which can lighten the dead load or the weight of the structure and may have a buoyancy for a certain application. Another example will be strain hardening cementitious composite, SCC in a short form. It contains a huge volume of synthetic fiber to create a network of fiber when the concrete cracks and deforms. It allows the concrete to have a substantial ductility under loading and good impact resistance. As nowadays sustainability takes center stage, researchers are also actively pursuing the integration of renewable or recycled materials into 3D printable composites. Components like recycled aggregates and natural resources like rice husk ash. These are generally offering not only ecological benefit and the values, but also enhanced material properties as well at the same time. They are currently used in a limited proportion, so more effort needs to make to decrease the volume of the cement to increase the sustainability value. While concrete stands as the conventional and go-to choice as always, alternatives like geopolymer, alkali-activated materials have emerged as promising contenders. These materials involve highly alkaline chemicals which activates the precursors like metakaolin, fly ash, slag to have a binding ability like cement. These materials often have a very good and competitive strength and sustainability aspect and the durability profiles. However, they have yet to entirely displace traditional concrete due to many factors like regional variations in chemical availabilities and safety issues and cost competitiveness. Today, we've briefly gone through the basics of concrete 3D printing material and what are the considerations for the material formulation. We also discussed the alternatives for other special functions, sustainability, and no cement options as well. In the forthcoming video, we'll look deeper into the complex of the fresh behavior of 3D printable material as a perspective of rheology to analyze printability of this material. I extend my gratitude for your presence in this part of our program. Let's pause out for now and see you in the coming video. Bye for now.